Alexey of ClickHouse will talk to us about a reverse DNS map he made.
Thank you. So my presentation is about DNS, but not just about DNS, not only about DNS. And actually this idea originated as an internal company contest. We made a contest for every employee of our company about this. Take any dataset you like and make application out of it. And it was just for 1 or 2 days. And apparently I was the only participant in this contest. So I have a lot of fun and I have this presentation.
So you won.
Yeah, I won. I got nothing for this, but I won. So I need some idea, I need a nice data set, and I need a way to visualize and analyze this data set. And to get a data set, the easiest way is to get it from the internet. And we will get internet scale data set. So how to get it? From DNS. And just basics. You can do forward DNS request, and the easiest way to do it from a command line is to just use the host command line tool, and for Google it will output IPv4 address, IPv6 address, and something else. And you can do a reverse DNS request for IP address. It will output something resembling the name. But for Google, for the same IP address, for Google it outputs something strange, .1e100.net. Question for you, what does it mean? 1e100.
1e100 is the scientific notation for the number they call Gogol.
Yeah, absolutely. So the point is reverse DNS records don't have to point to the original name. They actually cannot, because a lot of names can point to a single address, and actually they can contain about anything. And you can also use the more advanced tool dig, where you specify the type of record you want to get, and you will get the answer from your DNS server. And now a question for you. If PTR records don't have to be precise, they can contain anything, an arbitrary string, you can't count on these records to contain what you need. Why do they even exist?
For mail servers mostly.
Yeah, for sending emails, and also for nice infrastructure observability. So when you run something like MTR, it is like traceroute, you will get also these names from reverse DNS records. And the idea is to take IPv4, which contains less than 4 billion something IP addresses, slightly less, and just do reverse DNS requests for all of them. So how to do it? There are a lot of tools ready for that, like Mass DNS, or there is a library GNU ADNS. They are fast. From the README of Mass DNS, they say if you run this tool, you will get all the results in less than 1 hour. But the problem is, if you do it from home, most likely your internet will break, and your internet provider will break your internet, and you will have to call them. If you do it from your hosting provider, from AWS, from DigitalOcean, or whatever, it is also not a good idea. They don't like it. At least, even if they don't restrict it, it will be good if you communicate in advance. If you contact them, explain your use case, explain what exactly you will do, so they will not worry. But I am introvert. I don't like communicating with anyone. So I wanted to find another way to do it. Yes, so from home, not a good idea. From data center, not a good idea. My friend was blocked for this. I asked him to do it, and he was blocked, not me. From the cloud, also not a good idea. But let's take a look how DNS can work. What protocols exist? It can work over UDP, port 53. It is unreliable. It is not secure. It can work over TCP. It is not secure, but more reliable. There is DNS over TLS, reliable, secure, but heavyweight. There is also interesting protocol DNS over HTTPS. It is just an HTTPS API where you connect and request a record, and it will give you a result in one of several formats, including the original binary format or JSON for convenience. And there is Cloudflare DNS over HTTPS server. There is a Google DNS over HTTPS server, and probably many more. And interesting that you can even you can even use it without the domain name. If you use something like Cloudflare.com, you have to resolve this name in advance using a different method, like writing it in the hosts file. But you can write HTTPS just 1111, which is the address of this DNS server, and it looks quite nice. And there is also DNS script over TCP and over UDP, and it's actually a mess because even for encrypted DNS you can use more than 3 different protocols. I decided to check if I can use Cloudflare DNS over HTTPS. So the API, if I use the most convenient one with JSON, it looks like this. You specify your request, the type of record you want to get, and you will get JSON with all this information. It can use over HTTP2, even HTTP3, and HTTP 1.1, so everything works. And with the HTTP2, I can use pipelining with multiple requests, and it also works. You can use it from curl. I have read carefully the documentation about if I will just do several billion requests one day, will I violate their terms of service? And apparently I just did not find any mention of it. And I thought, so Cloudflare is such a big infrastructure provider. If I do plus just 1 billion requests, no one will notice, right? They supposedly processing trillions of requests every day, if not hundreds of trillions. So I did it. I also prepared a table for results in my database, in my favorite database, which is ClickHouse, the best analytical database. And this table is simple, date, time, and JSON with a string data type. And then I wrote a simple shell script. Let's read this simple shell script. So first of all, there is a SQL query inside. And this SQL query will skip all reserved IPv4 addresses like 127, anything, link local, etc. And it will generate ranges of the first 3 numbers. And then I will take these ranges and also parallelize by the last number, the last octet, and I will parallelize using curl. And I will generate a command that will query these 256 addresses with a single HTTPS request using curl. And I piped it to bash because I just generated these commands. And then I piped it into ClickHouse client finally to insert into the database with this another SQL query insert into. But it is just a 1-line shell script. You can see it. Okay, so what happened? I have run it. I have left it for a day. I went to sleep. And when I woke up, actually, nothing actually happened. So I did it from a single machine. I did not parallelize by many machines. And I tried to be gentle, so without using too much parallelism. The question is, how long did it take? A day? A day. Okay, any other? 2 weeks. couple of hours.
Hour.
2 months. No, actually it took about 10 days. So it was not fast due to these HTTPS requests. But at least no one complained. I was a little bit paranoid that no one complained. So yeah, around 10 days. So I went to this service. This service is named Gray Noise, and it represents an interesting kind of observability for the internet. It is named Internet Telescope. What is Internet Telescope? It is a bunch of servers across the world that are have some ranges of IP addresses. The ranges could be quite big, and they just listen to anything that comes to these servers. They open every port, they log every UDP packet, and they just listen and collect this data. And if someone does a massive scan of the internet, these internet telescopes are likely to get this noise. So the service is named Gray Noise, and I went to it and I found that it detected a DNS over HTTPS scanner. So probably me. But then, then I checked the information, and apparently it is not me. It is just every time something happens, and I don't have to worry. And even if I was detected, it does not mean that I'm a bad guy. I'm not a bad guy, trust me. Actually, I did not have to do this scan because there are open data sets of historical DNS scans. One of them was available from the project Sonar from the company Rapid7. Unfortunately, they no longer host this data set. At least they no longer give it for download. So at least I did an interesting exercise. So let's take a look at this data set. 3.69 billion records. It is not 2 in 32 because some addresses are reserved. The data set size is 13 gigabytes, and this is not even parsed. Compression ratio is 65. The raw data set, if we take just these JSONs, it is almost a terabyte. And to parse it, I used this simple SQL query. Let's not read it. Regular expressions, JSON extract, etc. And here is the parsed data set. Time, status, flags, IP address, and domain, IP. Let's take a look inside. The columns are compressed quite good. And the parsed data set is even less, not 10 gigabytes, but 5. So I can look, and it looks plausible. But now a question for you. Do you know what is the most popular TLD, top-level domain? You say .com. How many people will say .com? .arpa. Maybe. How many people will say .net? Let's take a look. It is easy. .net, .com, and .arpa. Either I just removed it from, but probably it is not that popular. I'm not sure why it is not here. It should be here. We will take a look. So .net is the most popular. Now a question for you. What is the most popular second level subdomain? Or first level, depending how do you count. Co, like Co UK, Co GP. Any other options?
Also
Net. What? Maybe. Let's take a look. I think you are all wrong.
Oh no.
And the second, for some reason, Comcast.net. And the third is BBTech. What is it even about? But probably you know.
Comcast is the home. The address is for the home.
Okay. Okay. Now, the next thing I did is I tried to find all reverse DNS records containing ClickHouse, the name of my favorite database. And I found a lot of them. A lot of them also with company names. And what I did, I sent this list to our sales team. Actually, I could use different tool. What it is? It's Shodan. It shows 23,000 ClickHouse servers are visible on the internet, probably because they are not secured, like it was with DeepSeek. But probably for some other reason, like they are secured, but handshake goes to them. Currently, it is 33,000. And I want to get more from this data set, so I need visualization. And the most obvious example is to make this map. This picture is from 2006, from XKCD, about representing the whole range of IPv4 using a space filling curve. So the curve that does not go like the scan line, but the curve that goes like this, filling all the space. It is difficult to say, but better to visualize. And also another example, also not from me, it is from 2018. Almost exactly what I want. But I want it bigger and better. So I have made another one-line shell script. It is this. I will draw a picture with SQL. And this SQL query will calculate first significant subdomain. Like abc.co.uk, ABC will be the first significant subdomain. Then calculate a hash, SIP hash 64. Then from this hash extract 3 bytes, RGB. And then use another function, Morton decode, that represents a space filling curve. And it will generate these pixels. And I will make it like a text in the format named Portable Net Map, PNM. And after all of this, I convert it to PNG. And it looks nice. Here is the picture like I wanted. And we will dive deep into this picture in a moment. But now, yeah, this is even more. It is zoomed. But I want any one zoom level. So I generated it with 4K resolution using that script. Actually, I want a full picture. And the full picture will be 4 billion pixels. 65K by 65K. So not 4K, but 65K. And 65K displays don't exist as of this moment. But I can do it interactively. Yes, we can generate a 4 gigapixel PNG, and actually I tried it. But when I tried to open it then, most of viewers were failing. Actually, some were not failing, but just slow. But most were failing. And then I decided to generate an interactive page, HTML page, like Google Maps, allowing to zoom inside a lot of tiles. And there are different tools for that, like OpenSeaDragon and Leaflet. Leaflet is more used for maps, and OpenSeaDragon is more used for something like scans of museum pictures, drawings. And it appeared not too difficult, so I have written another script to generate tiles in different zoom levels. And here is several lines of a loop for zoom levels, a loop for x coordinate of a tile, for y coordinate of a tile. File name will be like here. And here is the same SQL query to generate a picture and convert to PNG. Done, done, done. I left it for a day and it finished. now I have a bunch of tiles, and I want to arrange them into a service, and the service is here. Let's take a look. So here it is. Here is our map. We can zoom inside. We can zoom even more. Let me try. What will happen if to this violet something? Do you know what it is? Could you please try to guess? Comcast? Let's take a look. No, it's Amazon. But what is interesting, if I zoom even more inside this violet thing, I can see a lot of different dots. And the question is, why inside Amazon I have these different dots with reverse names defined specifically? And the answer is?
I guess email again.
Yeah, for sending emails. For sending emails, they... Okay, let's zoom back. And it is actually so beautiful. I spent a whole day just looking at this picture.
It is pretty good. Wow.
Now let's go back and see. So every click also generates a SQL query to this table, and from JavaScript it is easy to do. Just use this fetch request with a select query inside post, HTTP post. And it works because I have the primary key in the table. It is a point request. It is fast. And to make a service, I created a user. I set up limits, quotas, read-only access. And this HTML page from JavaScript directly queries this service. Takeaways. Please don't be afraid. You can use ClickHouse for data analytics. You can use ClickHouse for DNS analytics. And you will find something new. You will have a lot of fun. Maybe you will find creative way to test and break something. The source code is available. It is really easy. HTML plus 2 shell scripts. And that's it. By the way, we have a dinner today, but unfortunately it is full. So please don't don't look at this slide.
You are not welcome.
Thank you.